Hi guys, here's the video for chapter 8, lesson 1. So our focus for this chapter is looking at right triangles. We're going to continue to expand on some special qualities that right triangles have. Today we're going to focus on something called the geometric mean. So when I say the word mean, hopefully that rings a bell where you're like, oh, I've done something like this before. Think about your mean, median, mode. Can you think of what another word to describe mean would be? Mean is basically an average. So if I were to say, find the average of 10 and 4, what I'm saying there is find the number that falls in between 10 and 4. So to find that, we would add them together and then divide by the amount of items that are in my list, right? There's only 2 items here, so I divide by 2. And 10 plus 4 is 7. 7 divided by 2 is 3.5. No, that's 14. Sorry. 10 plus 4 is 14. 10 plus 4 is 14. Divided by 2 is 7. So I kind of was like jumping ahead in my brain and dividing the answer. So answer is 7. The average of 10 and 4 is 7. So when it comes to a geometric mean, it's basically let's read this. The geometric mean between 2 numbers is the positive square root of their product. So to describe what that is, it's really multiplying out 2 numbers and finding the square root of it. Okay, so if I were to look for this geometric mean of 10 and 14, what I would do is I would multiply them and square root. So 10 times 4 is 40. So the geometric mean of 10 and 4 would be square root of 40. And we're going to write our answers either as a simplified square root, which this is not, or a decimal. So let's write this as a decimal. We just plug this into our calculator, find square root of 40, and that's 6.32. So let's round to the nearest tenth, 6.3. Okay. Looking at these below, if you see a perfect square, you don't really need your calculator. You can just think of this as square root of 4 times square root of 4. Well, 4 is a perfect square. That would be 2. This would be 2. So 2 times 2. So that would be 4. The answer, the geometric mean of 4 and 4 would be 4. Let's look at number 3. So we could do 6 times 9, and that would be square root of 56. Let's find that as a decimal. Let's plug that in. And that's 7.34, and round to the nearest tenth is 7.3. Okay. Number 5, 12 times 20 is 240. So square root of 240. And that as a decimal, plug that in, it's about 15.5. So why don't you guys work the rest out? Let's do 7 and 11, 10 and 13, 10 and 12. Do those. Take a look at 6, see if you can do it without the calculator, and I will give you the answers. We're not going to worry about fractions on here right now. We're just going to do the whole numbers, okay? Okay, so I wrote the answers on here. You can double check. 6, notice they're both perfect squares, same as 11, but I didn't even see that until I wrote the answer down. So number 6, that would be 2 times 5, right? As perfect square of 4, square root of 4 is 2, square root of 25 is 5, so 2 times 5 would be 10. So the answer is 10 there. All right. So bringing this into our triangles, I'd like to look at something with you here. I created this extra sheet because I want to use this to help you understand how the geometric mean plays a role in looking at parts of our triangle. So the first thing I want to tell you is This drawing I have here is basically a right triangle. See, here's the right angle, split into two other right triangles. So I've got a right triangle on the left and the right. Now let's bring what we looked at last chapter into this, where we've got proportions. So the proportions of these triangles, if I kind of break this out, where I have the smaller one, the other side, the right triangle, the triangle on the right here that's been split, and then this entire thing turning it around and right here. Let's label the parts. So looking at this, it looks like I have 5 right here. This is what we call an altitude, and so the altitude is like the kind of like the height of the triangle, but it's really just making a right angle from the base of the shape to the top, the very top of the shape. So that's 5. This altitude is actually really this base, that's x. And then this hypotenuse, the long side of the right triangle, hypotenuse is y. This one I can just bring down directly, x, 12, and z. And then this one, I've kind of got to turn around. So y is right here. That's like with the right angle, right? Connecting to the right angle. Then the long part, the base of the triangle connected to the right angle is z. And then this long side is the entire length. So how do I find this entire length? 5 and 12 together. So that would be 17, right? Which that's just 5 plus 12. Okay, so we've got our proportions. Let's use these proportions to help us find the missing parts. So I know that these two are proportional, these two are proportional. So I could say 5 over x is proportional to x over 12. I'm just using kind of what I know of proportions from the past. I could do, let's to find y, maybe I could connect this triangle, this small one, and this big one, because they both have y. So setting up my proportions, I would have 5 to y is proportional to y over 17. And then finally, to do z, maybe I would do these two, right? So I could do, I'm going to use these two sides here because I have a number and then an unknown. So I'm going to do 12 to z is as z to 17. All right, notice something here. Got x, y, and z diagonally across. So when I multiply them out, I've got x times x equals 5 times 12. Here I've got y. Another way to describe y is y squared, right? Y times y is y squared. So y squared equals 5 times 17. Here I've got z squared equals 12 times 17. All right, now to get y by itself, or x by itself, or z by itself over here, this would become x squared, right? I could write that as x squared. So I could square root it to get x by itself. So basically the square root of 5 and 12 equals x. The square root of 5 and 17 equals y. And the square root of 12 and 17 equal z. All right, this has led to an interesting discovery, and it has created two theorems. So let's take a look at what this discovery is. Here's the key information. Looking at our triangle that we started out with, x equals 5 times 12, okay? Y equals 5 times 17, and z equals square root of 12 times 17. You might not see the discovery yet. I'm gonna write it out here. If you do see the discovery, then that's good eyes on you. So, geometric mean altitude theorem. The length of the altitude, so remember the altitude's kind of like the height. It's like this height right here. is the geometric mean of the two parts of the hypotenuse. Okay, so let's take a look what that means. If I have a triangle and it's split into two parts, here's my right triangle. This part, we call that the altitude. It's the geometric mean of the two parts of the hypotenuse. So remember, the hypotenuse is the longest side of a right triangle. This is the longest side. It's almost like that slanted side, right? That doesn't make the right angle of the right triangle. If this were 2 and this were 3, the distance of x is equal to the geometric mean of the two parts. So that would be the geometric mean of 2 and 3. Okay, so that's an example that goes along with the geometric mean. So that example would probably go with what we have right here. Okay. Now, as you can tell, this is the altitude, the two parts of the hypotenuse 5 and 12. Okay. The geometric mean leg theorem says something similar. The length of the leg, so this time we're looking at the leg. Now, a triangle has two legs, right? So this triangle, a right triangle, has both sides that are not the hypotenuse are basically the legs. So the legs would be y and z. Length of the leg is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse that's adjacent to the leg. So we'll talk about this. So I'm just going to say the part of the hypotenuse adjacent to the leg or touching the leg. So looking at these two parts here, if you can see these two parts, that follows the leg theorem. So we're looking for the length of this leg. To find the length of this leg, it is the geometric mean of the entire length and the part touching that leg. So the hypotenuse, the entire hypotenuse, 17, times the part of it that's touching that leg. So 5 is adjacent. This part is adjacent to y. So it's 5 times 17 square rooted equals y. And that's right here. Y equals 5 square root of 5 times 17. Looking at the next part, z. Z is the entire hypotenuse times the part of it touching z. So 12 is the part that's adjacent to z. So the length of that would be z equals 12 times 17 right here. I know it's kind of getting messy a little bit, but let's use this as an example, okay? If I want to find all these parts. Um, oh, shoot. Okay. Let's say that this is D here, okay? D would equal square root of y times x. B would equal the square root of y plus x times, which part is touching B? Y is, right? Y is adjacent to B, so times y. A is equal to the entire hypotenuse, add it, find the entire length, so y plus x times x. And that's how you would find it. Now, if I wanted to, if I knew the entire length already, which the entire length is given to me at C, so I can actually replace this part with C, right? That's just C. So if that's given to you already, you don't have to re-add everything up to find it. So using this information, let's do our parts here, okay? To find x, x equals the square root of the two parts multiplied out, geometric mean of the two parts of the hypotenuse. So 1 times 3 is 3, so x equals square root of 3. Number 2, let's find x, y, and z. So x equals 2 times 5 square rooted. So x equals square root of 20. Y, well, the entire length of the hypotenuse is 7, right? So that would be 7 times the part touching y is 2. So that would be square root of 14. Z, 7 times the part touching z is 5. 7 times 5. So that would be square root of 35. And then please, if you can, write your answers as a decimal. It says round it to the nearest tenth. So square root of 20. Here. Square root, oh, this is not 20. 2 times 5. I don't know where I wrote 10. This is 10 here. Typo, right? So 2 times 5 is 10. So square root of 10 is 3.2, about 3.2. Square root of 14 is 3.7. Square root of 35 is 5.9. Those are the answers. Number 3. Z is geometric mean of 1 and 8. X is the geometric mean of 9 and 1. And y is the geometric mean of 9 and 8. This would be 9. This would be 72. So square root of 8 is 2.8 roughly. Square root of 9 is 3. Square root of 72 is 8.5. All right, those are our answers. Okay, let's take a look at 4. Let's keep filling out like it is, okay? So, same idea. I just have different parts given to me. Square root of 3 equals square root of y times 1. This leg, square root of 12. I'm going to write it over here. Square root of 12 is equal to square root of y times y plus 1. And then x. X equals y plus 1 times 1. All right, let's see if we can find y. So to get rid of the square root, we can square, do the opposite. So guess what? If we square both sides, then I have y equals y times 1, which really is just divide both sides by 1. That's just 3. So y equals 3. All right, to find x, we can plug y in place of that and work that out. Now in this one, I guess I didn't really have to solve it because I already have y. So if we wanted to plug that in just to double check to see if it's square root of 12, we could just double check our answer. 3 times 3 plus 1 is 4. So 3 times 4 is 12. Yeah, that works out. So I think 3 is a good answer there, right? So now to find x, we just plug in what we have for 3. 3 plus 1, sorry, what we have for y, right? So 3 plus 1 is 4. 4 times 1 is 1. Square root of 4 times 1, well, isn't that a perfect square? Square root of 4 is 2. So x equals 2. All right, let's see if we can do 5. Ooh. The altitude theorem, using to find the altitude, 2 equals geometric mean of the two parts of this hypotenuse. Z equals 2 plus x times 2, and y equals 2 plus x times x. Okay, here's the thing. I think it would help us if we found x first. So we can apply the same idea to get rid of this, this root. I can just square both sides. Now I have 4 equals 2 times x. Divide by 2 on both sides, x equals 2. So that's going to be really helpful for me in solving solving z and y. So x equals 2. Plugging that in, 2 plus 2 is 4. 4 times 2 is 8. Z equals square root of 8. Y, looking at y. Y equals 2 plus 2, because x equals 2, times x, which is 2. So it's the same thing, right? 4 times 2, which is the square root of 8. And the square root of 8 is about 2.8. Okay, last one here. This time they gave you the entire length, but we don't have this part, right? We need that part to solve for y. So how could we find that? Well, this part is 2. What would this part be to make 6? Well, that would be 4, right? So now why don't you guys try number 6, see if you can work that out. Pause it and see. I'm going to work it out over here. Y equals square root of 2 times 4. X equals 2 times 6. Z equals 4 times 6. Okay, so square root of 8 is about 2.8. Square root of 12 is about 3.5. And square root of 24 is about 4.9. Those are the answers. All right, that's all I have for you guys.